Hello, my name is Sebastian Gallo, and I'll be teaching you about the empirical rule. Now, the empirical rule is used to predict, test scores or understand patterns like height or weight. It is to do with standard deviations, and it applies to the normal distribution, which is a symmetric bell-shaped graph. The bell-shaped graph looks something like this, with the mean in the middle, which is mu, and the standard deviations away from the mean, which look like this, which this being 1 standard deviation, 2 standard deviations, and then 3 standard deviations. With the third standard deviation, you put 2.35 on each side. And the percentages would be 68% for 1 standard deviation, 95% for 2, and for 3 standard deviations, 99.7%. So those are the basics. That's what you need to know. Now, let's start with an easy example. Now let's say we got a test scores with a mean of 70 and a standard deviation, which is this little sign right here, of 10. What percent of, someone may ask, what percent of students scored between 60 and 80? Since 60 is 1 standard deviation away from 70, and 80 is 1 above from 70, meaning plus 10 or minus 10, this falls within 1 standard deviation. The answer is 68%, because this is 1 standard deviation. Now, if you look at it on this chart right here, on this bell curve, you see that here there's 1 standard deviation, and that makes sense because the mean is 60 and the standard deviation is 10. So if you go 1 standard deviation either way, it's only 1. So this is 68%. Now, to make it a little harder, we're going to use a mean with height of 68 inches and a standard deviation of 3 inches. Now, someone may ask what percent of people are between 62 and 74 inches of height. Now, if you look at 62 and 74, you see that it's a multiple of 3. So if you multiply the standard deviation by 2, which is 6, you find that 62 and 74 are both 6 numbers away from 68, which means it would be 2 standard deviations away from the mean, which equals 95%. Now, on a bell curve, this would look like this with the mean in the middle. You write the 2 standard deviations, 13.5, and you would shade these two since it applies to 2 standard deviations. So your answer would be 95%, since that is 2 standard deviations, and 62 and 74 are both 6 inches away from the mean. Which, the way you find the percentage is you find how far the numbers you're given are away from the mean. Now, you won't always be given that. Sometimes they may ask you something else. Here's another question that you may be asked. Let's say they ask you what percent of data is between 1 and 2 standard deviations. Now, that may sound strange, but we know that 2 standard deviations equals 95%, and 68% of standard deviation is 1 standard deviation. 68% is 1 standard deviation. So, with this information, they're finding what's between them. So, what we do is we subtract the 2. 95 minus 68 equals 27%. And since they're trying to find 1% of data is between 1 and 2 standard deviations, you find what's on one side, not both. So if you look at this bell curve, you see that it says 13.5 on each side and 34 on each side. Now, since you're finding what's between the first and second standard deviation, you're going to minus 65 minus 60, 95 minus 68, which is 27. And then you divide the 27 by 2, since there's two sides to the bell curve, and that equals 13.5%. This 13.5, the way you describe it, the way you answer this question, I would say, is you say, so, so the way you would say it down here is 13.5% is between 1 and 2 standard deviations on one side. Now that is only for this. Now you may ask, what is the data beyond the 3 standard deviations? Now, as I showed you in this chart right here, I only showed you 3 standard deviations, but beyond this 99.7%, there's still 0.3 remaining before 100, correct? Now, for those 0.3, there's two tails. These two tails are both 0.15. Now, these two tails, you may not be asked about them a lot, but it's really good to know them, because if you are ever asked about beyond 3 standard deviations, or you get an answer like that, you know that you have to add 0.15 to your answer at one point. So your two tails are 0.15 at the end of your bell curve. And so with this, we subtract 100 minus 99.7, we get 0.3. And since we're, again, finding one side, we divide by 2, we get 0.15, which is each tail. And so we get 0.15 on each side. That is the data beyond 3 standard deviations. That is good to know, always. Now, we can move on to a real-world problem. A real-world problem could be, suppose SAT scores have a mean of 1,050. I'm talking about SAT scores. And a standard deviation of 200. Now let's say they ask you about 1250. Let's say what percent of students scored above 1250? So, above the x is greater than 1250. So we know that 50% of the data is above the mean, meaning that 1250 is one standard deviation above the mean, because 1050 plus 200 is 1250. So, and 34% is between the mean and one standard deviation. Now, the way you show this on a curve, here's the curve, would be like this, with the mean in the middle of 1050, and then 1250, which is one standard deviation away, and you could also put 850 down here. They're trying to find what's above 1250. Now, since you put 34 here, and 50%, because this is one standard deviation, and one standard deviation, it's asking what percent of students scored above 1250. So 50% of the data is above the mean, and 50% is below the mean, of course, right? So with this 50%, this is counting all of this space right here. But there's a 34 here. So what you do is you subtract 50% minus 34%, and you find the remaining data, which is over here. And this remaining data would be 16%. So we can say that 16% of students scored above 1250, and we shade this region right here. And that would be your answer. 16%. We can say in a sentence that 16% of students scored above 1250 on the SAT. The way you show this on your curve is by shading this region above here. So, with that, always keep in mind that 68% of the data is always going to be 1 standard deviation away. 95% of the data will be within 2 standard deviations, and 99.7 will be within 3 standard deviations. And also remember that there's always going to be the tails, which are both 0.15. And also realize that data cannot overlap, meaning that if you find data on one side of the mean, remember that you need to subtract by whatever data is on that side and whatever standard deviations you're using. The empirical rule is a good and powerful rule that helps you estimate probabilities very easily. Thanks for watching. And I'm here.